Turkey has marked a new chapter in its defense technology advancement, with the successful development and testing of a domestically produced Ramjet engine intended for long-range strike systems and advanced air-to-air missile applications. This achievement places Turkey among a small group of countries capable of producing high-performance, airborne propulsion systems. The Ramjet program, which began several years ago but accelerated in the past 3 years, is designed to meet the growing need for long-range missiles capable of countering evolving threats across the region. Traditional rocket-powered missiles rely on solid or liquid propellants for propulsion. On the other hand, use atmospheric oxygen and maintain long-range propulsion, enabling significantly greater range and higher ultimate performance. For Turkey, whose defense industry has rapidly expanded into UAV, cruise missiles, and air defense systems, acquiring Ramjet propulsion is seen as a natural next step. Developed by a Turkish defense technology team and tested in a series of static and flight tests, demonstrated durability and combustion stability across a wide range of altitudes and speeds. Engineers emphasized that this breakthrough required mastery of several advanced fields simultaneously, including materials science for high-temperature components, computational aerodynamics, fuel injection optimization, and guidance propulsion integration. One of the most notable achievements is the fuel system, which uses a controlled throttle mechanism to enable variable thrust, something crucial for modern air-to-air combat. Traditional ramjets, while powerful, often operate at a fixed performance level. The throttle capability allows the missile to conserve energy during the cruise phase, and then accelerate during a terminal intersection. The Turkish Ramjet engine is expected to serve as the propulsion backbone for several new missile programs. The first is a long-range strike missile intended for land and sea platforms, which is expected to reach a range of several hundred kilometers at high supersonic speeds during its flight. This class of weapons is designed to ensure rapid and highly survivable engagement against high-value targets, including command centers, naval assets, and strategic infrastructure, with increasing regional emphasis on anti-axis area denial (A2/AD) capabilities. Turkey aims to ensure its deterrence and precision strike options remain credible and resilient. In the air-to-air domain, Ramjet engines are anticipated to power new, long-range beyond visual range, BVR missiles that will complement Turkey's current missile inventory. Modern air warfare relies heavily on first-shot superiority, and nations with Ramjet-powered BVR weapons, such as the UK, France, and several others, maintain significant advantages in high-altitude, high-speed engagements. Turkey's entry into this elite group signals a maturing domestic aerospace sector and gives its air force the capability to field missiles capable of striking targets at extreme ranges while retaining energy. During the final interception, this capability is expected to integrate seamlessly with Turkey's upcoming KAAN fighter aircraft, advanced UAVs, and existing fighter fleet. The combination of a long-endurance unmanned platform with long-range propulsion could enable Turkey to develop new operational concepts such as cooperative engagement, expanded sensor shooter networks, and multi-platform targeting. Ramjet-powered weapons could also enhance Turkey's naval air defense posture by enhancing the interception range and reaction time of future ship-mounted missile systems. The development of a domestic Ramjet engine has significant strategic implications. Historically, access to advanced propulsion technology has been severely limited, with many countries unable to acquire it due to export restrictions or political constraints. By mastering Ramjet design and production, Turkey reduces its dependence on foreign suppliers and gains the freedom to innovate at its own pace. This autonomy is especially important as global competition increases and supply chains become more politicized. From an industrial perspective, the program has fostered collaboration across universities, government laboratories, and private defense companies. The expertise gained through the Ramjet project, particularly in high-temperature materials and computational modeling, is expected to extend to other areas of aerospace manufacturing. The resulting ecosystem strengthens a broader workforce and expands Turkey's competency in critical technologies. Furthermore, having domestic Ramjet capabilities opens the door to defense exports. Many countries seeking advanced missile technology face similar procurement challenges, and Turkey's track record as a competitive and reliable exporter, particularly in UAVs and precision munitions, positions it well to capture a share of this niche market. While international regulations and alliances will shape export destinations, demand for affordable, high-performance propulsion continues to grow globally. Despite successful test campaigns, developing a Ramjet engine is challenging. Ramjets operate in extreme thermal environments, requiring components that can withstand sustained temperatures above 10 degrees Celsius while maintaining structural integrity. Engineers have developed new alloys and composite materials specifically designed for the engine's combustion chamber and intake. Other challenges include ensuring stable ignition and maintaining efficient fuel-air mixing at various speeds and altitudes. Comprehensive simulation models are required to predict airflow patterns and pressure dynamics, which are then validated through intensive wind tunnel testing. Looking ahead, Turkish engineers are already exploring the next evolutionary step, the scramjet supersonic combustion ramjet. While a ramjet slows the incoming airflow to subsonic speeds before combustion, a scramjet burns air while still at supersonic speeds, enabling hypersonic speeds above Mach 5. Although still in the early stages of research, early indications suggest that Turkey intends to pursue this frontier. In line with the global trend toward hypersonic technology, the infrastructure and knowledge accumulated through the Ramjet program will significantly accelerate progress toward future scramjet designs. This Turkish achievement comes at a time when global defense technology is undergoing rapid transformation. Countries are investing heavily in longer range, faster, and more maneuverable weapons to maintain deterrence and respond to emerging threats. Ramjet-powered missiles are becoming a hallmark of next-generation weaponry, and Turkey's entry into this field will undoubtedly impact regional calculations. The ability to deploy fast, long-range, precision-guided systems increases Turkey's strategic depth and allows it to engage with more complex security environments with confidence. Furthermore, this achievement underscores a broader narrative. Turkey's defense sector continues to demonstrate that sustained investment, local innovation, and strategic vision can yield results previously thought impossible. With new systems slated for production in the coming years and more advanced propulsion technologies on the horizon, Turkey is poised to shape the future of missile and aerospace development in ways previously speculative. The successful development of the Ramjet engine is not simply a technical milestone. It signals Turkey's entry into a new era of high-performance defense capabilities. Built on self-reliance, scientific rigor, and long-term strategic planning,